All right, in this one, we're going to draw a graph of this. So we're going to kind of put all these pieces together, see if we can come up with a graph. So I'm going to list the steps that we're going to follow to find these over here. So let's start with, it says find the domain. To find the domain, we set the denominator equal to 0. So I set that equal to 0, x plus 2 equals 0, and x minus 4 equals 0. Because when I set this equal to 0, I have to set the different factors equal to 0 to get this one. I get x is equal to -2. When I move that one over, I get x is equal to 4. So those are the numbers that will give me a 0 in the denominator. So if I think about a number line, and I know I can't have -2, and I can't have 4, but I can have everything else, how would I write this in interval notation? Well, it would be, the domain would be -infinity to -2 union -2 to 4 union 4 to infinity. That would be my domain. For the vertical asymptotes, well, this is really easy because those are just the x values that you solved for when you got the domain. So our vertical asymptotes are at x is equal to -2 and x is equal to 4. I'm going to go ahead and I'm going to zoom in a little bit, and I'm going to actually draw those vertical lines at, we're going to have one at -2. I'm going to make sure I label these as well. And then I'm going to have another one at 4. Great. All right. So continuing on, removable discontinuities. Removable discontinuities happen if I have factors that match up on the numerator and denominator. And since there are none that match up on the top and the bottom, there are no removable discontinuities. Horizontal asymptotes, this is where we're going to look at degrees. What's the degree on top? The degree on top is 0, right? What's the degree in the denominator? The degree on the bottom is, well, this is an x to the first, and that's an x to the first. So the degree on the bottom is 2. Since the degree on the bottom is greater than the degree on the top, I'd encourage you to take a look back at the last video, but we know that there's a horizontal asymptote at y equals 0. So I'm going to draw that horizontal asymptote at y equals 0. Slant asymptote, that's the same thing as an oblique asymptote. That only happens if the degree on top is 1 greater than the degree on the bottom, so we're going to say there's none of those here. X-intercepts, you set the numerator equal to 0. Now, it doesn't really work here because when I set my numerator equal to 0, I look at my numerator, and my numerator is actually 1. And if I do 1 equals 0, that doesn't make any sense. So there are no x-intercepts. Y-intercepts, just like the last chapter, you plug in 0 for x. So let me zoom out a little bit, take a look. We're going to plug in a 0 for x, so it's going to be 1 over 0 plus 2 times 0 minus 4, which is 1 over 0 plus 2 is 2, and 0 minus 4 is -4, which is 1 over -8. So I'm going to actually, let me pick a different color for this. I'll do this in green. We're going to put, so that's like right here, right? And now it says to use the graphing calculator to help us draw a picture of what this is going to look like. So let's go ahead and let's put this in the graphing calculator and see what that's going to look like. I'm going to have to use Desmos. And when I take a look at what this looks like, you can see I've got the kind of setup. I've got my vertical asymptotes, I got my horizontal asymptotes. It looks like this graph is going to come kind of above the y-axis and shoot up, and then it's going to kind of do this upside down parabola thing right here and then come back over to the side. So that's going to help me put the pieces of this graph together. So it's going to come from over here, and then it's going to shoot up. And then I'm going to have an upside down U thing going here. And then it's going to continue over here. Actually, let me back that up. I got to go through this point, so I'm going to make sure I go through that y-intercept of 0, -1/8 right there. And then we're going to continue this piece onwards that way.